Okay, so this video is about squares and square roots. First, I'm going to tell you what a root is. Okay, so how roots work is a root is the inverse of an exponent, meaning it cancels out exponents in the same way addition cancels out subtraction, division cancels out multiplication, and vice versa. And this is how it works. Okay, I can show you that 27 breaks down like this. If I were to prime factorization this, that means get it down into its prime numbers. 9 times 3 is 27, 3 times 3 is 9, so that's how we got all that. So in general, if we actually thought about this, if I take 3 times 3 times 3, I should get 27. So 27 is the same thing as saying 3 cubed. 27 is the same thing as saying 3 cubed. Now, how this works is that, you see this cube root right there? What it's going to do is actually cancel out this exponent. So if I took the cube root of 3 squared, or cubed, it would cancel out this part, and it would cancel out that part. And all you'd be left with 3. And that would be the answer to this, is the cubed root would be 3. Same thing with the 16. This is actually called a square root. The reason why we know it's a square root, it doesn't have a number there. So that actually means 2. So if I break down 16, it's 4 and 4, 2 and 2, 2 and 2. Okay? So, this is actually 2 to the 4th power. And I'm square rooting this, because that's what that thing was up there. This was a cubed root, over here. So this is a square root. So that means that we can only cross this out. Like, the idea behind this is that things come out in a group of 2. Okay? So technically, the answer to this would be 4. Okay, the reason is it looks like this. This is technically 2 to the 4th power, or 2 squared, and 2 squared. If I square root both of these, which we can do, it would cancel out both of these things, and we'd be left with 2 times 2, which would be 4. These are the things that we are going to be dealing with. All this is asking is, what number times itself equals 16? And in that case, it's 4. So if I took the square root of 36, okay, once again, think about it. What number times itself equals 36? Well, 6 times 6 equals 36. So you'd know the answer to the square root of 36 would just be 6. That's how square roots work. That's how roots in general work, but we're going to be dealing with just square roots. Now, we can see x squared. So we're going to be dealing with something. In PEMDAS, when we were doing solving for equations, we only did the adding or subtracting and the multiplying and dividing. We never got to the exponents. Well, this is the time we'd get to the exponents, because adding gets rid of subtraction, multiplication gets rid of division. Exponents, you get rid of them by doing square roots. So if you see right here, we have x squared. So to get rid of it, we have to square root it. What that does is the square root cancels out with that squared term, and you're left with just x. But what we do to one side, we have to do to the other side. So let's do it to the other side. So this is what this is saying is 25, the square root of 25 is, think about it, what number times itself equals 25? The answer to that is 5. 5 times itself equals 25. But just like absolute value equations, we're going to have 2 answers. Because not only does 5 times 5 equal 25, but negative 5 times negative 5 equals 25, because a negative times a negative equals a positive. So in this case, we'll have x equals 5 and x equals negative 5. This next problem. Okay, this was pretty easy because we just did quick. This one, we have to once again do PEMDAS backwards, because guess what? It has a variable. Step 1, get rid of any of the adding or subtracting. So we're going to first get rid of this minus 6, or get rid of the 6 by subtracting it. The next step would be to get rid of the 2, and how we do that is you divide by 2, because that's multiplication division, which is part of PEMDAS. So you divide by 2, you get x squared And then finally, you should get, that's 36. You should square root both sides. This gives you x equals, as we spoke about it earlier, 6 times 6 equals 36. So the answer to this one should be 6 and negative 6. Okay, I'm going to have you do these two. I'm going to give you the answer. I'm going to show you how to get the answers and like that. I'm going to give you a sec to do them. So pause the video, then you can do them. Alright. Step 1 would be to subtract 7. You get x squared equals 64. Then you would have to square root both sides to get x equals 8 and negative 8. Now if you can't figure this out like right away, if like you just know that 8 times 8 equals 64, what you can do in your calculator is just go one by one. Take 1 times 1. Does that equal our answer? No. 2 times 2. So on and so forth. You would have gone all the way down to 8 times 8, and then you realize that 8 times 8 equals 64, and that would have given you your answer. But that's an easier way of figuring that out. What about this one? Well, PEMDAS backwards means to add or subtract first. That gives us 5x squared equals 80. Then you would divide by 5. It gives us multiplication division. And then finally you would square root, and you get x equals 4 and negative 4. Alright, now we talked about squares and square roots. Now I'm going to show you what they look like when graphed. Okay? When you have a square root function, the general form looks like this. And as you can tell, we have our a, our h, and our k again. So once again, they mean the same thing. A means shrink or stretch, h means x value, k means y value. Okay? In this case, the parent function, it ends at 0, 0. That's where we're looking at. We're looking at this part right here, and that's what we'll always be looking at for these type of graphs. So, in this first one, we notice this is the parent function at 0, 0. So we're looking at just this one. I'm not going to make you do any of the a's with these because it's really hard to figure those out. So we're just always going to be finding the x and the y value. And we're always looking at the end where it like curves off like this. So this is the end right here. We're going to put a little dot. The x value is at 5. The y value is at 3. So our h equals 5. Our k equals 3. So the equation is pretty simple. It's all you got to do is plug it in to the this thing up here. So we're not going to deal with the a's, so all we're going to do is the square root of x minus 5 plus 3. Okay? Once again, we're looking at this one down here. The x value, the h is negative 2. The y value, which is k, equals negative 4. We're just going to plug them in. Be x minus h, which h is negative 2, plus k, which is negative 4. These two negatives makes a positive, so you get x plus 2 minus 4. So these I will not make you graph. All you'll have to know is how they move and how to make the equation when you're looking at the graph. The next thing is the squared functions, or what are better known as quadratics. You probably heard the quadratic equation somewhere, and that's to deal with these types of graphs. So once again, the a is stretch or shrink. The k is the y value, and the h is the x value. Okay? Now, you're looking at where these things two meet. Okay, so this is just like an absolute value function. We're seeing where the two things meet, which is always at this end. This is the parent function, and we know it because it stops at 0. So you'll be able to tell that from these two. So we know this one right here is the parent function because it's at 0. So that means we're going to be looking at this other one. We're going to look at where they meet. They meet right here. Okay? So this is our formula. So we're dealing with the h, we're dealing with the k. The h, well, the h is 6 because that's where it's at. The k is 3 because that's where that one's at. So then your equation is x minus 6 squared plus 3. Because all we did was take the h, replace it, k, replace it, and that's all we did. We didn't have an a, so we don't have to put anything there. For this other one, same idea. This is the parent function because it's at 0, 0. So we're looking down here for this one. Where they two meet is right about there. Our x value is -5, so that's our h, -5. Our k value is -3, meaning our y value. And once again, all we're doing is plugging in, so it's x minus h squared plus k. So it should be x minus h, which is -5, squared plus, or -3. This will turn into a positive, so it'll be x plus 5 squared, and I'm just going to put -3 at the end. You can put plus -3, either way works, but this makes it look prettier. Finally, is graphing. I'm only going to do 2 of these, so I'm going to be quick about it. This is just like the absolute value. When you're graphing this, you first always have to find your h. The h is inside the parentheses. So for example, the h here would be -5. Well, if we look here, neither of these two things have parentheses. So that means neither of them have an h, or actually their h is 0. So we're going to make our XYT chart the same way we did before, where we're going to put the h in the middle. We're going to put 2 numbers above it, -1, -2, and 2 numbers below it. This time we're just going to plug in for x again. So there's an x here, there's an x. Our x right now is -2 for the first one, so it's going to be 3 times -2 squared. Now, -2 squared means taking that number and multiplying by itself. So whatever number comes out of here should be positive. So -2 times -2 becomes +4. So it's going to be 3 times a +4, which equals 12. Next one is going to be 3 times -1 squared, which equals 3 times a +1, which equals 3. Next one's going to be 3 times 0 squared, which is just 3 times 0, which equals 0. And then you're going to notice something. When I start doing the other side, I start getting the same numbers, just like in an absolute value equation. So, as you can see, this is 3 and this is 3. So I can tell you right now, if this is 12, this will also be 12. So that's a shortcut to help you out. Now if I graph all these, I'm going to find -2 on the x, go up to 12. I'm going to do -2, go up to 12. -1, go up to 3, 0, 0, so on and so forth. Same thing over here. So we're just going to plug stuff in. So it'd be -2 squared plus 5 which equals 4 plus 5, which equals 9. Next one, negative 1 squared plus 5, which equals 1 plus 5, which equals 6. 0 squared plus 5, which equals 5. And then these two right here, because we know this is the vertex, the active value of the vertex, since this is 6, this will also be 6. Since we know this is 9, this will also be 9. That's the only way you can make the U shape. So the only difference between this and a absolute value is this makes a U shape, absolute value makes the V shape. So 1, 2, 3, 4, 5. I can't graph the 9s on here, so I'm just going to make it look like this. That's how you do graph quadratic functions. Alright, thank you.